Hello. All right. Wait a few minutes to get started. I see Sam in chat. Hello, Sam. I expect that today will be a little bit light because it is a Sunday versus last time I did it was on a Monday, but that was a day off for me. So I'll get started pretty soon. And let's see here. I think everything is good for the Twitch chat. Be aware, I'm still using shield mode, so your first message might take a minute to show up for everyone. And hello, Sam. Otherwise, we'll get started in a few minutes. Please do let me know. Last time we had a lot of trouble with the audio being echoey. Please let me know if it's still that way. If it's not, then I would appreciate hearing that too. Or if the volume is too low on the microphone and you can't hear what I'm saying, that would also be helpful. Excellent. No echo this time, Sam? Maybe a bit quiet. Okay, let's bump it up. All right, is that better? Thank you. I also realized, I suppose, Sam, you're the only person here yet, but oh, hello, Alicidra. Well, we're going to see if we can reduce the slow mode on you. I'm a little bit new to the moderation controls on Twitch, so let me see what I can do. Yeah, it's not obvious to me. So sorry about that. Bear with me. Again, pretty new to this. Only my second stream. That's perfectly fine, Sam. Write long messages. I also realized that last time Twitch does not let us keep recordings of sessions around for longer than 14 days, and on September 1st it's going to be changing to 7. So I have started recording this session as well, and I'll probably put it up on my personal YouTube account, and we'll have some back streams for people to watch if they want to watch me flail around in Elixir, like we're going to do today. But I do think it is more fun to flail around together. Last time was really great feedback, really great set of people joining, a lot of old friends like Sam Lennery in the chat, and we'll hopefully get that same sort of vibe going. I'd like to do this more regularly. It's just my personal schedule has not been such that I've been able to find a time that works consistently. Meanwhile, I've noticed, 3 or 4 times in the last week, Jose Valim has been live coding, so I need to step up my game a little bit. that said, why don't I switch over to the coding screen and we'll get going. And thank you, everybody, for joining. Let's get started. And if you came last time, you will be aware of what we're trying to accomplish here. If you did not, I'll give you a really brief introduction. The purpose of the stream is to recreate an HTTP client, high-level HTTP client that I used at a previous job. And I built it with help from some colleagues there. I would probably say like 80% of the code was mine. But the thing that was really sad about it is they couldn't or wouldn't open source the client. Now, if I had YOLO'd it, maybe we would have it publicly today. But there are really only about maybe a dozen or so principles that this was built upon. And so I think it's not going to be that hard to reproduce most of what it did. And then hopefully over time, what we can build is something that people will want to use because it works out of the box, but is flexible enough to fit within their infrastructure. But the main idea here is that there are a whole bunch of resilience patterns that we kept having to build into all the different clients for internal services and for third-party APIs. And it was really frustrating to go, well, this client used HTTP poison, and this client used HTTPC from Erlang, and this one, and like it was just kind of all over the place. And then we had a desire to both make those more resilient but also observable. I think it can be harder to build an instrumentation after the fact. So that's actually what we're going to focus on today, is throwing in some default instrumentation. Now, several years ago, at the time I wrote this client the first time, there were not as many things available in the community for tracing specifically. So we're going to look at some of those. I've already taken a peek at what's available, and there's some great stuff from some of my colleagues who happen to be in an Elixir Discord with me, but who are on the EEF instrumentation, telemetry, observability committee. I forget exactly what it's called, but they're focused on making Erlang and Elixir services applications observable. And so they built a lot of add-ons that support OpenTelemetry. So we're going to probably pull in one of those. And it's some really great work by Brian Nagley. And it's very similar to what I was doing previously. But we'll also pull in telemetry, the Erlang library telemetry, and have a look at how we might create hooks so that people can add their own metrics or logging or other kinds of instrumentation. So I think that about covers it for the intro. And you may notice I have two editors up here. Out of frustration, I've recently picked up in the last week and a half the Z editor, and I really like it. If it is too small for folks over here on the right, please let me know. I'll bump up the text size, and we should be able to feel like everybody can see it. Yes, I'm dual wielding. Unfortunately, Z doesn't support org mode. If it gets org mode, then bye bye Emacs forever. Thank you. It is a little small. Let's update. Oops, wrong window. Let's update that. Okay, so I'm gonna put it up to 17 today, and I'll put the terminal up to 16, and that should improve things. There's that better, folks. And if that is still too small, let me know, and I'll bump it up even farther. And I may want to rearrange the windows eventually, so hopefully that's not too disturbing. So I want to go ahead and put in here some things about what we're going to be doing, and this will go into the module doc as well, because last time we created this this bit that slurps in the README, broken at this dot comment, and then puts the rest of it into the module doc for the Hardhat module, which is the root module, and that's just this. So it reads the readme.md file, it splits it on that string, and then it gets the second thing after that split. Okay, so we want to say what's included, and this will also act sort of as a checklist for later. And what we're going to say here is integration with telemetry and OpenTelemetry instrumentation. If I can spell. And again, I'm happy to take requests to bump this up to even larger. I realize I can't really control, Zed is a pretty new editor. I can't really control the size of the project view here, but I didn't use that much on Emacs anyway. So other things that we're going to do, and this is included in the future topics, but I'm not going to do today. I'm going to say, we'll say circuit breaking. Let's put it up in here. Connection pooling per client module, circuit breaking for failed requests repeatedly. I'm not going to talk about circuit breaking today, but we will visit that later. Timeout and deadline support. And we'll say automatic retries for failed requests. And there will be a bunch of other things, but let's get started on point 1 today. And I'm going to hide Emacs. If you want to follow along on the commits and everything, please do look up on GitHub Sean Cribb's Hardhat. In the meantime, let's go over and look on Hex, because we are going to add some dependencies to the project now. So I'm gonna here, let's close the Z settings. So we're gonna add some stuff here, and two things we want to add are telemetry. So there was actually just came out, I think on Thursday, an episode of Elixir Outlaws where we were talking with someone who had given us a presentation at Codebeam Europe about using telemetry. So really recommend listening to that. It's fun discussion, but the main thing to learn here about telemetry is that it's really just an event dispatcher. But the goal there being we want to emit some events before and after requests that include some timing information potentially. The other thing that we're going to look at is tracing. So OpenTelemetry is the current probably most popular, best supported standard for distributed tracing. I don't really feel like I need to give a whole talk about why you need distributed tracing or why you might want it. It is, I think if you go beyond a monolithic application, you're going to want tracing. And even then, even if you only have a monolithic application, you might want tracing still. It's going to give you a lot of information. You still have to add things. You have to add spans around important parts of your code. But it gives a lot of insight, and you don't have to be on the box to read it. You do have to set up some infrastructure. This is the main downside. But there are even like free services or free to start services that you can rely on to collect OpenTelemetry data. one thing that's important to know about OpenTelemetry, when you select this package, this is the entire setup. So what I mean by that is the OpenTelemetry design, and this is one of the things that was frustrating reading the specs the first time I did this, was that OpenTelemetry is designed for object-oriented languages that have limited abstractions around these sort of side effect-y concerns. So a lot of their architecture in the specification is about keeping the implementation of a tracing library separate from the specification of it. So you have this idea of an OpenTelemetry API, which is like, here's the spec, here's all the things that you can call, but it doesn't specify what implementation supports that API. So it's kind of like this facade. Like if you were in Java, it'd be a bunch of interfaces, and you would expect to have in your application, libraries would use those interfaces, but your application would supply it. So this is really good for like so many of the platforms from a couple decades ago that were very object oriented. They're like all about dependency injection. They have runtime container things that inject this sort of information into your app. So that's kind of where that's coming from. We don't really have that problem as much in Erlang and Elixir. But what this does allow us to do is having OpenTelemetry API. So we don't want this one, just to be clear. This is the full implementation with the default implementations of the tracing and the metrics and all that stuff. We don't want that because we don't want to start up OpenTelemetry under this library like as the full stack. We only want to have the hooks to call into whatever someone's deployed application has. Okay, so I hope that was clear enough. Oops. If not, well, let's add OpenTelemetry API. And here. But I do want to be able to test. So we're going to add this, but only for test. Okay. That will let us start up the OpenTelemetry stuff. We'll be able to register an exporter in our tests that just forwards the trace information to our test PID, and that'll be enough for us to test that our implementation of the OpenTelemetry is working as we expect. Okay, is this clear to everybody? Also, if this is your first time, welcome. Thank you for coming. Okay, so I need to restore my Emacs that I minimized. So we're here. We basically added the dependencies. I don't think that there's anything specific we need to do yet. But let's look at this curiously named. Oh, well, if you're not a coder, I'm very sorry. This is probably not the stream for you. Thank you, Sam. And Totally Sane, I'm very sorry. This is going to be very technical, but bear with me. Okay, curiously, you're looking at OpenTelemetry. There's a list of dependent libraries here on Hex. That one looks like it might be interesting. OpenTelemetry Tesla. Okay, Tesla middleware that creates OpenTelemetry spans and injects tracing headers into HTTP requests for Tesla clients. This might be perfect. So, spoiler alert, it is really good. this is very similar. Here's the repo that it's in, because I'd like to look at the code that we're interacting with here. So let's look at the OpenTelemetry Tesla middleware. And maybe they'll bump up the size there so it's a little bit more readable. Let's have a look at what's going on in here. This is really similar to what I did originally, so I think we might just use this one. But let's read through it real quick and get an idea of whether it's going to work. So one thing that is new that has happened since last time is that they've actually turned. So I mentioned there's a spec for OpenTelemetry, right? They have a whole bunch of conventions in the specification that say this is kind of a cross-platform, system way to refer to different attributes of a trace span. Yeah, I'll bump up once more. Thanks. Let's go up to 19, and we'll just have it ginormous. 18. Okay. It could also be the fact that I'm on light mode over here and dark mode over here. Okay. Thank you for the notice about the size. Maybe next stream I will lower my screen resolution a couple ticks on my primary display, and then let's see one more time. Huge. Okay, so there are a couple of responsibilities for the OpenTelemetry. The main thing is that distributed tracing is most useful when you can see what activities on different services correlate with one another, right? So there's two main things there. One is when you go to make a call to some other service, you start a span. So spans, if you have never seen distributed tracing, we could probably Google it, but the idea is that you can create a tree of an entire set of related activities through your whole infrastructure. So each participating application needs to emit what are called spans. So this is, I did this activity for this long, and here's some things associated with it. What this is doing for us is when we start making a request. So we're writing. For example, let's look at our test real quick. So we have this test client, and we just we're going to call test client get and some host. So what we want to see when OpenTelemetry is active on this client is that we'll create a span that is information about this is an HTTP request. This has method get. This is to this URL. Maybe there's some finer grained things on there, but the main thing is, and we need to name that span. So what we're doing here is Tesla middleware. If you're not familiar with the Tesla middleware, no, not Fable. We're going to go Timon Tesla. So Tesla is similar to Faraday in Ruby, and there's some other clients that look like it. But the main idea is that you can have a very basic HTTP client, and you can enhance it with different middleware, sort of like Plug or WSGI or Rack or any of these things that are kind of about building up a stack of behavior. So for example, if we say logger, this is going to, let's scroll down to, here's the logger middleware. You can provide a log format. Lots of documentation to scroll through. But the main thing here is there's always a function in this module called call. And it takes 3 arguments, E and V, which is the Tesla struct that specifies what's in the request. Next is the set of things that you're going to call next. So this is just a function that you call. And then ops are options that were supplied when this middleware was added to the client. So if we went up here and we said use tesla.middleware.logger, we could put comma here and say what's an option that they use. So let's say filter headers authorization. Yeah, rack. I'm dating myself. Thanks. So this is what gets passed. The contents of this get passed into this ops argument, right? Okay, and then we'll see. Hey, they're timing the Tesla run next, and actually next is they don't say it here, but I forgot. It's not a function. It's a list of the next set of middlewares to call. So you call Tesla run and you pass it env and next, and it'll pull whatever is in that list, and then execute that, and that thing should call Tesla run next, if depending on its behavior. Okay, and then it gets a format, and determines the log level, and then it calls logger log. So this is just outputting log messages. So that's the sort of thing that we're doing. We're doing in this. Okay, I'm going to remove that from our code because we don't want the logger in there. No good. Okay, so this one, it looks like it's going to construct a span name, which you can override, it looks like, with the options. Okay. And then it's going to use this macro with span. So that will open, that's not helpful, that will open a span, right? Okay, so it's going to open a span, and then it's going to give the span name, and it's identifying that this is a client span. So we're making a call to some other service. If that service receives the propagation, which we'll talk about later on, then it should make a span on its own side that says it's a server span. And this is how you can get that relationship lined up, is you say this is a client span, this is a service span, and then if it's doing anything internally inside the service, it'll have internal spans, which are different from client and server. Okay, and then so we're going to take the env, which is the contents of the Tesla request, and then it's going to, let's see what this does. Okay, let's jump to that symbol. Well, it didn't. Okay, so it's just setting up some options for later, I guess. Okay, so if we didn't supply, okay, so we'll look at that maybe further down through this pipeline. And the next thing it'll do is call maybe propagate. So let's see where that is. Okay, so this is important, and we want to provide some options for this. So maybe propagate says that for if we want to make sure that the client span that we're doing on this part and the server span actually relate to one another, there's this idea of passing the context of the trace through the request, and then the server should be able to collect that, and then it can say, oh, I know that this this particular request I got relates to this trace. So that the idea eventually being that when the client from our side and the server both submit the information about the spans they created to a central collector, then you can correlate those things across different services. Okay, sorry, I'm spending a lot of time explaining and not a lot of time coding, but I think it's important. Okay, so this is going to use the stuff built into OpenTelemetry API to inject the tracing metadata into the request. So here it's saying take whatever is in the current process state for this process, this Erlang Elixir process, right? And then you're going to use this propagator, which I think has a default, right? So it says get text map injector, okay, and then that's taking the Tesla EMV again. So this is something you can pass into the yeah. So this is how do you inject this into the request? That's what this is doing. So it takes the propagator, takes the Tesla request, and then pass it through this this lambda here. So it's going to say Tesla put header key value, right? Okay, so this is just putting the trace parent and any baggage or any of the other things that come along with distributed tracing into the request. That seems good. Okay, so then after it's set up the propagation, oh, note also here, we can choose to do none if we don't want it to propagate. So like, let's say this was calling Stripe or something. They have their own tracing infrastructure. We don't want to send our trace IDs to them. So that might be a case that we want to expose to people. Turn it off completely. Okay. And then it's going to run the request. So note that it's env being piped through here. So this is the Tesla request being piped to the first argument. Okay, and let's look at set span attributes. Okay, so we got, it's either successful or not, and we got the Tesla env back as a result. If we got anything else, then we don't want to set attributes on it. But if we did, we can extract attributes from this request, right? So let's see what build adders does. Okay, takes. So this is adding important information about the request that was made and what its result was to the span that we created at the beginning. Okay, so what we're going to do here is let's construct the whole URL. And then it's going to use, so it's going to extract the method, the URL, the target. Now notice this trace here is actually not required trace. This is the semantic conventions. So it's trying to use well-known attributes for this trace span. So that's all good. And then it's, if the content length is in the response, then it's going to put that in the set of attributes. Okay, and then HTTP method, it's just turning it into an uppercase string. That's fine. Okay, and then and then the very last thing it sets, we're going to go scroll back up here. It says handle result. So if the request was successful, then okay, so this is maybe something I don't necessarily agree with. When the status is greater than 400, I don't necessarily. Okay, maybe that's fine. We might want to provide some defaults for additional OK statuses. I don't think, because of HTTP semantics, I don't think that all 4xx codes are actually errors. For example, I was thinking of, and this won't apply to this, but there was a thing at work where we were checking for the existence of an object in S3 before trying to store it. Okay, so that we wouldn't necessarily overwrite it, or we could avoid that extra upload cost. In our traces, that ends up coming back as an error because we do a head request and it returns, or no, rather, so like if it doesn't exist, we do a head request and returns 404. So that gets marked in our tracing as an error, but if we're trying to store it for the first time, we actually expect that to not exist. So it's a little bit I don't necessarily agree with marking so many of these statuses as errors. I would prefer to say if something is a okay, so taking another step back, another thing that we may want to think about here is, overall, so far I think this is really good, but if I want to distinguish between things that caused the whole client connection to shut down or bail out in some way versus things that are at the HTTP semantic level that are not really exceptions. Like the request succeeded, but you got a status you didn't expect. Like I think that's sort of a different situation than the whole request didn't work at all. Like we got, like econ reset, connection reset, TCP code, or something like that. That's or we had a low level timeout. Those are different situations than, we expected a 200, okay, and we got 404 not found. So I'm not certain about the answer to that. We may just go with this, and then if it doesn't fit, then we can implement our own. So obviously we can see how to implement this. There's not that much code there, and it's really cleanly put together. So yeah, let's go ahead and just add this. And what's interesting about this is I think if we do that, we don't need OpenTelemetry API because its dependencies include it, right? Excuse me. It's not clear to me why this depends on OpenTelemetry telemetry, which is a mouthful. What does this library actually do? Okay. So yeah, I'm not certain why this, because it doesn't look like in the code that it uses that at all. Let's look at their, yeah, maybe it uses it in test. Let's take a quick look. No, I'm not seeing it. Okay. That is really strange that it pulls it in. I kind of don't like that because it's not strictly necessary for this problem. Okay. Well, let's go ahead and fetch our dependencies. And compile them. And of course, you know, if there's anything that you don't understand and I can explain briefly, I'm happy to do that. In the meantime, I'm just going to try to explain as I go. So let's get into that. So our goal here is, let's go ahead and add this to our stack. And we'll have some interesting choices to make here. So in the last stream, we created this builder module. So this builder is the thing that turns our the module where you call use Hardhat into a Tesla client, and we are setting the adapter with this macro call here. We also started this defaults module, which includes some things that we want to be defaults, but we want it to be easily overwritable from a custom client. So I'm going to minimize this for now, and we'll get more code going here. So what we need to do is we need to we've got the OpenTelemetry Tesla in here. We need to be able to make the how to put this. We need to be able to put the OpenTelemetry middleware like it's the very last thing. But we want the person who's creating their own client for a new service to be able to put their own middleware in there too. So like we want to make sure that this goes in there, but we want to make sure it goes last. And part of the problem is if we just said middleware here, open, and what is it? I'm going to have to bring that back up, aren't I? Right. So if we did tesla.middleware.OpenTelemetry, okay. If we just did this, because of the order that this macro happens in, we're going to get this happening before anything else that the user calls. So we don't want to do that. What we want this to do is be run at the end. So I'm going to pull that out, and I'm gonna have to remind myself, and we may have to do some mixed decompile here at some point. Let me see if I have that installed. Hardhat dot. I think I did it in the last stream to expand it. Yeah, archive.install Scala decompile. Yeah. Okay. So let's try that decompile again. And then you see what happened here is it expanded this and actually that's not what I wanted to do, but okay. Let's save it. Okay, so I'm sorry. We wanna pull this out. I accidentally closed the wrong window. What I want to do is not hardhat.builder, but hardhat, right? Okay. Yeah. We'll maybe look at that later if we need to. But I've got decompile in there. That'll help a lot. Okay, so we're going to put a little thing in here, which is before compile, hardhat.builder. And if we look up in the, let's look in Elixir before compile. I think it's in module. So this is a hook. And it's a compile callback. So let's look down at the compile callbacks. And interestingly, what will happen is this we say we use Tesla Builder here. It also has a before compile hook, and that's how it turns all these things that you're doing at the module level into functions that it can call when you call, say, foobar.post. So let's look at compile hooks, if we can jump down to those. Compile callbacks. Okay, so before compile, a hook that will be invoked before the module is compiled. This is often used to change how the current module is being compiled. So it's a macro, and it's supposed to return a quote, just like we did here with using. So using is what lets us call use hardhat.builder. So let's go in here and so we're going to def macro. It was before compile. Yeah, with dunders. Before compile dunder, and it takes the env. We don't actually care about that right now. And let's quote do. So our goal here is to inject the middleware that we want to happen at the end. So there may be some things, and I say maybe, there will be some things that we want to put up here at the front for general utility. Otherwise, we're going to put them at the end. And then whatever the user supplies happens in the middle. So let's say middleware open or Tesla .middleware.OpenTelemetry. I think that's what it was before. Arc. Yep. Okay. Now, I was going to talk about this separately, and I think we might do it later, but let's go ahead and put this one in there. Yeah, this callback ordering does break your brain. I think with Tesla, it's at least easier to understand that they are called in the order that they are injected, with the exception of the adapter. The adapter always comes last. So the adapter is actually a middleware in the Tesla parlance. So, but this is just, it specifies this always comes last. Or the other way you can think about it is if you think about it like the Russian doll thing, you're wrapping things. The Finch adapter is always the thing in the smallest doll, and everything around it just wraps it or has a precondition on it or whatever. Okay, so there's a very good reason why this has path params in here, and that's so let's say real quick, let's say we had a I can't really say true. Let's say we have a Mastodon client. Okay, and we use Hardhat here. We might want to make a function that says user profile, right? And then let's get their handle, okay? And this is just making this up. I don't know actually what the Mastodon API looks like, but we might say something like handle here, right? And then we can say path params is handle. And what this will do for us is make these kind of parameterized URLs consistent. And then the request specific information can be injected later. That's what the path params middleware does. And in fact, hex docs. Yeah, let's not Tesla. So middleware, path params. So this lets you template URLs. So like in this example, get user's ID, right? We're doing some of the same thing. Okay. So if we did something like this, then the URL supplied here will be used as the span name. And if we jump back over to GitHub, if I still have it open, yeah, okay. So here, when it creates the span, so it has you can pass an option of the span name. I don't know that we'll get into this, but there's a difference between compile time ops and runtime ops, and that was a pain point for me previously. But so it calls this private function get span name, and if the path params is there in the request options, it's going to use the URL path as the span name. So in our little example here, it would use /handle as the span name. Why does this matter? When you're trying to search for, hey, I called this URL, and I want to see what's wrong with this particular service, request to this particular service. Well, you can aggregate them more easily in your trace aggregator if they have the same span name. Versus if we said, well, my Mastodon client just put if we did something like if we did handle instead and we interpolated it, those would come out as separate span names. You wouldn't be able to see, well, what are all the requests that are for user profiles. You wouldn't be able to search for those or aggregate across their metrics. So it's better to use and then sadly from conventions, I'm going to just put this back, even though we're going to throw this away in a second. Although we may use this. Let's see. So the alternative is just HTTP and the method. Like, so HTTP get, HTTP post, HTTP whatever, like that's not that useful for aggregating across, but it's a sensible default if you don't know what the, so I can understand why they did this. This makes sense to me. The way we did it previously was not to put the path params after, as they recommend, not putting it after the telemetry. We put it before, but I think we may revisit this. Anyway, okay. So let's just leave that there. So now we should okay. Yeah, now we should have a working OpenTelemetry setup. So I need to figure out what we're going to do here. And I think we need to look at no, I don't want to search that. We're going to go to OpenTelemetry API and look at their documentation. Okay. SDK, right? Let's see what that jumps to. Yeah, okay. So let's look at the SDK here. Don't care about sampler, propagators. So there are a couple things we want to check here. So let's make some empty tests. We want to check that. Let's just record spans for simple requests, and then records spans for parameterized requests. Okay. And I want to see, where is this? Okay, so what we want, I believe, is the exporter PID. And I'm trying to remember how I registered that. It's been a while. We might just end up looking at the source of this app. Hotel batch processor. Yes. Okay. So that's deprecated. Kind of wish Brian were here, but I think he's on vacation. Okay, real quick, let's look at the questions. You say after presumably means for your middleware, you get the template and not the filled in URL. Correct. Yeah, for so if we put path params after, that means OpenTelemetry will use the templated URL for the span name rather than the one with the value filled in. Good question, Sam, and I'm sorry I didn't see it for a few minutes. Okay. So maybe we can just go to the source. Let's go to the source. Okay, so this is the application behavior for OpenTelemetry. Starts tracer provider. Sets the text map propagators. We saw that earlier. Application tracers. Okay. And let's look at the supervisor, because it might have some interesting stuff in here. Okay. So the span soup is what collects the tables, or has the tables of the spans, or it might be the tracer provider. Anyway, let's look at, hold on. There was something in here about, was it a batch processor? So the set exporter is deprecated. Okay, so set through OTel tracer provider instead. Let's see what that does. So we're going to get into the problem here of API and SDK being separate. Okay, so OTel tracer provider. Get tracer. So okay. Yeah, we'll just pass undefined for those, I think. Name, I believe, is supposed to be your application name. Okay, so this is a thing, like if there's no tracer provider running, it, so if it gets no proc, it just calls no op, returns no op as the tracer. But okay, let's look at what the behavior is. That's not going to tell us what we want. Okay, so we need to start a tracer. And I'm guessing it's this config that gets passed second. So hotel tracer provider soup. Sorry we're having to dig into the guts of this. I'm not really happy about that. But since enough has changed since the last time I did this, it's going to be a little bit of a challenge. Okay, so right, so this probably defines a child spec, which is a tracer provider, and we can give it okay, simple one for one. Tracer server. Okay, so a simple one for one is, if you don't recall this, it's a bit older, but it's similar to the dynamic supervisor idea that is in Elixir. Okay, so this is going to start a tracer server. So let's look at that module. New GitHub is so helpful. Tracer server. Okay, so it's passing these options all the way through. So when it calls start child, this option will come in there. So it starts a span processor. I think this is the thing we want. So maybe we're providing a name. Okay, hotel tracer server. Let's look at that. We're almost there. I promise we're almost there. Okay. So the span processor is important here. Init processors. I suspect that this is in the documentation somewhere. Really quick, let me look in the README. Span processor batch traces exporter. Okay, so maybe what we need to do is okay, so right, so let's look for this traces exporter in here. I believe we were in tracer server. Oh, right, but it uses the batch processor. Where did that go? As the default. What I want to do, okay, so if you're not following, what I'm trying to figure out is how do we tell the machinery that's set up, we want to export to the PID that is our test process so that we can get those spans and then make assertions on them. So this is the part I'm puzzling about. And it used to be such that you would call, and I'm just going to complain about being deprecated. I may just do that for the sake of expediency today. But used to be able to call set exporter. which would you would pass, you know, the options. The option, this would be like the exporter would be OTel exporter PID. The options, you would pass the PID of your current processes. But I think that this, given that this is deprecated, I don't see how OTel tracer provider gives the same the same thing. That's not even an API that looks the same or close. So I'm very confused about that. Right. Yeah, and by the way, this is all it does. Just folds over Net's table and sends span messages to your process. So, okay, well let's keep this in mind and see what we can do here. So bypass and yeah. Excuse me. Okay, so we have now that we have more than one test, I'm probably going to have to turn this to false. And the other reason why is that we have the possibility that if we're going to register the exporter PID, and we might just do it up here, that we're going to receive we're going to receive messages in our test PID, but we don't want those to break across tests. So like if we set it in one and the two tests are running simultaneously, we don't want to receive messages for the other test. So I think that we're going to have to sacrifice async true, unfortunately. Okay, so let's see if we can go ahead and install that. And I'm going to do it the deprecated way. I don't like this. It's going to complain. It says set through the OTel tracer provider instead. One more time. Let's see if we can. Right. Yeah, there's nothing in this API that, unless it's this OpenTelemetry tracer type, which I think probably just says module. Tracer module term. Okay, not helpful. Let's do it the old way. So, okay, here, OpenTelemetry batch, OTel batch processor. So we're going to say OTel batch processor, and we will say set exporter. We want to say OTel exporter PID, and then let's real quickly see what the options should be. Yep, it's just the PID, so we'll say self. Okay, so now in each test we should receive messages that are spans. Okay, so let's copy pasta this a little bit. Okay, so we're gonna, that's gonna be our default response for whatever client. So we're using the test client. I'm going to comment out. Was it? I don't remember what it is. In Z, we'll figure that out later, how to comment a whole block. Okay, so what I want to do here is assert receive. And we're going to get a span, and I don't actually care what it is right now. And then what we can do later is start to look at, we need to make a request, first of all. Yeah. Yeah, the Ruby SDSLs things are kind of throwing me, but as well. Sorry, Evan, and thank you for joining. Good to see you. So we're gonna do another request like so. In fact, I just copy this line. I assume you've been doing most of your stuff in Erlang directly or Rust or something, Evan. So I get it. I get it. Okay, and then let's just run mix test. And it's compiling all the things. Okay, so there's a problem. Middleware, there's no such import. Okay, so I think probably what happened here is we have a problem of ordering. So Tesla Builder probably needs to be in there first. And let's see if that fixes it. Logger awareness, okay. OpenTelemetry exporter net. Oh, yeah. Okay, so we're gonna jump over here. Where do you put those configs nowadays? It needs to be a config directory. Config. New file. Config.exs. Okay. Is it import? Or is it include? Include? No. Import. mix.env.exs. Okay, I don't even know if that works anymore. It used to generate this for you automatically. Okay, let's make it test.exs. And we need to make a so supposedly there's supposed to be like Elixir LS running in here, but I'm not getting any hints. So something to debug later. Okay, so here we want to do config OpenTelemetry. And I want to go back to the docs on this. Span processor batch. And we want to do traces exporter none. And then we've got maybe this is related to what we're supposed to do. Anyway, this way it's not going to try to start the OTLP exporter because we don't care about it. Sorry, Ignacio. Also, hello. Good to see you. Combination of nostalgia and PTSD. I totally understand. Luckily for you, you didn't have to write this code the first time. Okay. So our main problem here was that we were getting this undefined function middleware when what was happening was we were expecting Tesla Builder macros to be available. And I think I want to put in here an option that will clue us into it's happening right here, not not in, you know, this file. That's not where the error is happening. It's happening right here. Okay, so let's try mix compile first. Yeah, cannot compile file. Errors have been logged. Compile time atom or okay. Someone who remembers Elixir, help me out here. Import file. Yeah. No, that's IEX. Oh, config, import config. That's what we want. Import config. And this needs to do use config at the top. And we need to do use config up here too. Okay. It's import config. There we go. Okay, so let's try running mix test again. Okay, so it still doesn't know what that is. And it's still trying to start the OpenTelemetry exporter. Too much Rust recently. Yeah, similar for me, Evan. Okay, let's just throw this in here. And then maybe what we can do is say we don't care about, let's delete that file. We don't need more than one file. It's not a big deal. And maybe we say config env. That's mix release. Okay. Okay. And let's try that again, because I think that okay, so now we don't get those OTLP problems, but there's an issue in our before compile. So let's try to figure that out. And what I want to do here is look at some examples again, and maybe we'll get an answer there. Right, so before compile, that's what we've done there. I actually wonder if it's like you put it down here at the very end. I don't know that that's going to matter, but I think let's have a quick look at, because we did use Tesla Builder here, which should maybe if we require Tesla.builder or import only macros. So that's probably just a hack, because use Tesla Builder should do that. Yeah, undefined function middleware. Test client uses uses Hardhat, which in turn uses hardhat.builder. So everything that, like, obviously our first example would not have worked at all in the last session, right? So what we could do to debug this is, first let's just comment all this out. Here, let's learn Z. Selection. Shrink selection? No. Let's see if the command palette. Comment. Toggle comments. There we go. Comments. Okay, so that's okay. Command slash. Good to know. Okay, so if we remove that, then what we should get is that the test fails. Right. So that's what I expected. Was that we would get no span being sent, right? Let's, for the sake of argument, avoid the before compile and put it up here. And this is not what I want, eventually, but at least we could test that it's working, and I'm not crazy. Oh. Oh, hello. The word is not middleware because reasons. It's plug because other reasons. This is what happens when I go away from Elixir for too long. I barely know how to write this stuff anymore. Okay, so hope you had a good laugh with that too. That should, at least it compiles. Now we're not getting we are not getting any messages yet. So we need to look at why that is happening, and it's probably related to how I've set this up, the OTel stuff. So yeah, we don't actually care about pool here. That was a good call. Okay, so note it does start that exporter. What I would like to avoid is setting the PID via the application environment, so like application set env. I would like to avoid doing that because that would require us to stop and restart OpenTelemetry every freaking time, and I think that that's wasteful. So I'm not going to do that if we can avoid it. Out of curiosity, I want to see if there's anything in these tests, and maybe they do. Nope. I has a sad. Anyone else also? This used to be so much better. Okay, well, we're gonna copy pasta all this because I don't want to fuss with it, and I will. That can be. We can use the Elixir versions for that. It's basically the same module. Okay. So the other thing here is note that it has a 1 millisecond delay for batches. This will make sure that our tests don't wait forever for those spans to come through. Okay. Yeah, it's not set AMD. It's put, because why would it be named the same thing? Okay, so now we're getting the mailbox is empty. Let's see, both processor and span processor set in configuration, but only one should use. Span processors will be ignored. Okay, so I think what we want to do is say span processor instead. This is probably, their code is based on an older one. And see if there's it stopped. Okay, so oh, so I wonder, let's have a look at back at this, because these are kind of abbreviated. They're not the actual module name. I wonder if there's something else we need to be doing there. And I think we can look at okay. There was a thing, I'm forgetting where it was. Might be in the app. Let's look at the app, because I think there's a, right, OTel configuration. I wonder, right, fine, okay. Start. So we're starting a tracer provider. This config comes from, right, merge. So this is just, let's find that. I think it's an OpenTelemetry API. Nope. Apologies for the flailing here. OTel configuration. So processors is a list. They don't care about span processor. Okay, so interestingly, processors. So I think what we need to do here is in this setting, we'll remove that shorthand. Because I think what they were doing is they're kind of upgrading, excuse me, right, it's saying if there's span processors, then yeah, this is a bunch of like make the configuration easier to read, and we don't need that. Okay, so if I go back to the test, then what I'll do is instead of specifying span processor and processors, we will go back to doing that. Okay. Okay. So let's try our test again. Okay, we still get 2 failures. We're seeing it stopped after each test, so at least we know that's working. Okay. So, I mean, I can make it wait for longer. I don't think that that's the problem, but yeah, it still doesn't. Okay. Uh, in returning to cribbing from them. Okay, so right, so they're importing the OpenTelemetry records, which will probably be useful for us. Um, let's go ahead and put that in here while we're thinking about it. Okay. Format and save is still not working correctly. Okay, so we should be able to go now. It's not actually sending us the message, but we should be able to say something like the name of this is HTTP get, right? Because we're not using a parameterized URL. We're not passing any path parameters. And so we should be able to say that there's a span that has HTTP get as the name. I wonder, out of curiosity, whether these tests still work. Because there's not really, other than, I mean, we can re-copy paste this stuff. So it's exactly the same. And see if we can test that. Require record. Yeah. Okay. So I think we need to take a break from this because I think there's probably some simpler problems that we can solve. This feels kind of tied up in how the heck do you even run OpenTelemetry, and I don't know that that's the best use for our time. I'd like to wrap a few things up before we go, and because I'd like to spend less than 30 minutes or so more. We've already been going 90 minutes, and I feel like getting kind of stuck on some things that are not all that helpful. So we did include the telemetry library. So I think that what we can do is also, actually, why did I minimize that? We can look at Tesla if I have it open here. So Tesla has a library that includes telemetry. And the options on there, we should be able to tweak. Okay. So yeah, let's have a look at what this does, and then we'll potentially add it to our stack. In the original Hardhat, we made our own OpenTelemetry middleware, and rather than using the macro for the with span thing, it would manually call opening and closing spans. And I think that gave us the opportunity to put that and the plain telemetry hooks in the same place. So there's just going to be a little bit of a compromise here. And yep, let's see here. Okay, so right. So this is just calling telemetry execute for each of the positions in the life cycle of the request. Now, I kind of wish that this were configurable. I think maybe it's acceptable for this pass, and maybe what we'll do in the future is make our own. I think maybe making our own was a little bit too ambitious for this particular live stream. So why don't we add that? And we're in the builder, so we'll do it before the OpenTelemetry gets called. And then I think there was a way to tag it. So we can skips the test. Okay, so what we're going to do here is we're going to say tag. Is that right? Yep. Okay, so tag, and then we'll say skip true, or tag skip. Let's see if that works real quick, and then we can come back to that at some other time. Yep, so that's skipped, and that's not implemented, and we're going to say tag skip. Now, what we could do also before we go on is kind of take this and do a parameterized request. And then we'll just skip this. We'll just write the test and it won't succeed, right? But we could say user ID and ops path params and ID 5. Okay, so that will at least when we get the OpenTelemetry working, what we should see is user ID as the span name here, and then we can match on the attributes at some point, and figure out what that what the other attributes would be based on the contents of that. So okay, so let's give a new test for emits telemetry hooks for requests, and we'll do this again. Okay, so we registered that we're going to receive that. We want to have a look at some stuff here. So when it emits stop and start, okay. So let's say assert. We want to actually register a handler. Attach, and this is where the language server would help me a lot. Okay. Telemetry. Okay, so let's make a handler. And it's going to take Tesla okay, test PID self, because we're going to need to use that. And let's actually just say event, and it takes measures first and metadata, and config we don't care about. And we're going to say send send to test PID. Event measures metadata. So we're just going to make sure that we get that stuff. Get that attached. Telemetry test is the name, and we're going to register it for Tesla request. And it seems a little bit silly to be testing this for something that's already tested in the Tesla library. But I feel like what we're wanting to show here is that, yes, it's included. So if we ever somebody accidentally removed it, or we decide that we're going to implement our own, we'd want to make sure that these tests could still pass. And we're going to use handler as the function, and nil's the config. Okay, so now we've attached a telemetry handler, and let's do again like we did here. And then we're going to say assert receive. Instead of span, we're going to say the event is Tesla request stop. And then the measures, so there's gonna be a duration. So we'll say duration, match on that. And then the metadata, let's see how it constructs the metadata. Maybe we can make some assertions about that. So we can supply additional metadata potentially. But really the only thing that we know is going to be in there is the request env. Okay, and let's run that test. Mailbox is empty! Yay! I can't catch a break. So let's see. I maybe got the arguments wrong. Kernel send. Destination process message. Okay. So did we get... Okay, so... Right. It actually is fine. Right, so it's complaining about a local function rather than a module function, which is just a performance thing. Right. Performance penalty, call that. Okay, fine. But it should still work. If anyone has ideas, I would love to hear it, because this seems like almost the same problem that we had in the OpenTelemetry one. Now, I don't think we can generally. We could take advantage of the fact that this is just the same process. But yeah, let's try the timeout real quick. I can also make a less specific match. So we'll try that too. But I think given that it's saying the process mailbox is empty, The thing about telemetry hooks is they execute in the same process. So the only you know how we thought that the problem was where that was being called? I think it's that. Let's see if that fixes the telemetry. Aha! So, just to illustrate this, I think was being excluded. So macros are treacherous. Be very careful. What we're saying here is, so before compile are almost like these plug calls, in that the thing that you specify there will wrap anything that comes after it. Or rather, the thing, but it's inverted. So we want our before compile to happen before Tesla builders before compile, because we're using macros that Tesla builder defines. That's got to be it. Okay, so if we do this, then maybe we can get those other tests to pass, and maybe that was the problem here. Let me put these back and see if that test still passes. Okay. So let's try to restore these tests, and maybe we'll be okay. Okay, so we still didn't get, interestingly, it could be a binary verse. No, it says mailbox is empty. And the other assert span, assert receive span didn't work either. Okay. Let's just one more time try a longer timeout. Okay. So those are still not working. I'm going to say that OpenTelemetry PID exporter is brittle, question mark. And then we'll move on with our lives. At the very least, this is working. And we can verify that we're getting those telemetry hooks. So I'm pleased with that. But I am troubled by the fact that we did exactly the same thing as is in that other library, and it just doesn't work. So I'm going to have to give that some thought, maybe off stream. All right. Let's see. We cover. So we included the path params. We updated the builder macro. I do want to potentially revisit path params. Maybe we can do that. Do that very quickly. The main thing, and I'm not certain whether it's in Tesla, so let's have a look before I embark upon that. One thing that we had to do previously was that path params, yeah, it's still not. So we're going to make our own real quick. And let's go ahead and let's make a commit first. So I've been doing a lot of work without committing. And let's first add everything that was updated. Add the config directory so that we have OpenTelemetry correct for test mode. And we have our dependencies. So we're going to call this first pass at OpenTelemetry and telemetry integration. tests for OTel are skipped. Okay. So that is up there. And I want to... So I didn't finish my thought earlier, and this is going to be the last thing we do. I'm going to make a middleware directory for our middlewares. And let's make a new file in here, and this is going to be path params. Okay, so this is going to wrap the Tesla middleware path params. And the reason why is that you can put in path params a string that is not URI safe. So what I mean by that, you can't actually pass it in the URL, or it'll get interpreted incorrectly on the other end. So what we want to do here, we want to say Hardhat middleware path params, and we'll copy something like this. We ensure that all parameters are URL safe. Will you reformat my dot comments? No, you will not. Okay. Okay. So, let's say behavior Tesla.middleware. And we'll define the callback. And we don't care what the compile time options are because we aren't going to supply any. Okay, so then what we're going to do is right. Okay, so we're going to take path, let's see, if path params. Because what I don't want to do, we're going to say going to take key value, right? And what we want to return is key, and we want to do URI and there was some questions about, I don't recall, whether you use encode or encode www form. I believe we would want this because it will encode colon and slash, which are reserved, right? But encode www form, yeah, let's use that. I feel fairly comfortable with that. because it's valid for query strings. However, the other option is that we reserved and unreserved characters are kept unescaped. Okay, so if we do encode reserved characters, okay. The function will be called with each byte and string as its argument and return a truthy value if the given byte should be left is, or return a falsy value. So we could do encode value and say unreserved question mark. And that, I believe, would be basically it's like car unreserved, excuse me. That would be basically what we want. So truthy if it should be returned as is, falsy if it should be escaped. So right. So alphanumeric characters, tilde, underscore, dash, and dot. Those are safe. Okay, so that will be sufficient, I think, to list. And then else nil. So getting wonky with the format there. Their support for Elixir is not so great yet in Z, but work pretty great for TypeScript and for Rust, which is what I do during the normal days. Okay, so then we want to do something like env is Tesla put opt. Sorry. I should be looking in the docs. I'm looking in the freaking code. And it is put opt. Okay. So you say put opt. Actually, what we want to do here is reassign the env. So in this case, we're going to say so we want to get this processed, and then we want to say Tesla.put opt. So we only want to do this in the case where there actually is path params. Otherwise, we don't want to modify the request. Because if they didn't specify it and then we go and put it in, maybe that's not such a bad thing, like if we put it in as an empty list. But I kind of don't want to take that on right now. And then we're going to do a little trick. So we saw in that other one where you do Tesla run, and then we're going to prepend their middleware on there, so that we don't have to re-implement that logic. And we're going to prepend that on the middleware that's defined. Okay, and let's format that and see if it makes sense. No, we've got a problem here. I need an end on this function. Okay, I could probably make this as an ampersand function, but I think it's a little bit clearer right now. Okay. If you're still with me, I think we're almost at the end for today. Uh, any questions or thoughts on this? Yeah, the main thing there is if you're like putting in something there that has spaces or has reserved characters for URLs, you don't want it in the middle of your URL, potentially messing up the request. So we made sure that all those parameters are URI encoded. The There's a question potentially about, well, what if the field that you're providing is already URI encoded? In my experience, we didn't need to handle that, but I'm not sure for right now. So I think what we'll do is we'll go with this, and then let's go over to the builder, and we're gonna change this to be Hardhat, our first custom middleware. So the last thing we could do is add a test, which we didn't test the path params before. So say encodes non-URL safe characters in path params. Okay. So let's get this guy once again. And then, maybe in a future stream, what we can do is break these out into separate tests. So test files, but we have such little functionality right now. One file is probably going to do it for me. So I'm going to say, and we want the, it's not a connection, it's an env. Say that. So we're going to say localhost bypass port. And let's say user ID ops path params, and let's put so we saw what are the unreserved characters, so let's put some stuff in there that is reserved, like a %, ampersand, star. And okay, and this needs to be inside a list of its own. ID. Get that formatted real quick. Okay, and then we're going to say refute we're going to refute env.url. So what we don't want this to look like is the string directly interpolated. So let's just copy that. Because I don't know the exact encoding for those things, but let's run that test real quick. Oh, interesting. Okay, so actually in this test that I thought we were skipping, we are not. So this needs to be a string. Okay. Yeah. Right. Okay, so I constructed that incorrectly. What it's saying here is it's expecting something that's module name function arguments, and And what I need to do is say call here. And possibly an empty list. Okay, so we have a problem here. Localhost. I actually tried to look that up. Isn't that fun? Okay. Next time I'll copy paste it instead of trying to type it again. Okay, so that one passed. Now we could turn this into an assert and make it fail, and see what it actually converts to. So you can see that it converts it to the percent encoded that you would expect for a URL safe string. We could change our test to assert that. I think that's okay. But for now, I think it's better to just say our intention is that you will not have unsafe values interpolated in your path parameters. So yeah. And then I think we might be done for the day. So let's lib test. Let's add those. And let me bump up the terminal size here. Want to make sure that we have a good commit. Okay. Add Hardhat, or add custom path params middleware that encodes parameters for URL safety. The only time that I think this might not have worked was where the service that we were calling, it was a third party, didn't really decode URIs correctly. So I think it's pretty safe to put in there. And why don't we push and have a look, make sure that our CI is still running. And I'm sorry, folks, I'm going to have to bump down the size. That did not work. Okay. And our stuff is running, which is good. I think that it might be nice to check off this, but until I get that test passing, I'm not really comfortable calling that step done. And I think this is a good place to leave it for today. If you all have any questions, I'm happy to take them now. I know I was very focused on writing the code so far, but I'm happy to answer any questions that you have while we wait on the tests to run. Yeah, it's just dialyzer. What do I dislike about Elixir? That is a question of left field. I think sometimes I've maybe it's just I'm getting older. Maybe it's that I have been exposed to other paradigms, but I like the expressivity of strongly typed languages, which is not something you might think someone like me would say. People would say, "Oh, well, dynamic languages are more expressive." I actually find that for the Rust code I write, having like kind of forcing me to express my problem in the types makes me write better code sometimes. On the other hand, Elixir is very much a get it done type of language, which I can appreciate. I also have to write TypeScript every day too, which is, it also has a type system. I don't care for its type system as much. It can be helpful. Sometimes it's incredibly confusing. And sometimes it's oddly not specific enough. But for the most part, that's what I would say. What do I dislike about Elixir? I wish there were more ways to express certain sorts of things. And right now, my main thing I'm struggling with is remembering how to do Elixir. So you all are kind of witnessing some of that. I'm doing a lot of copy paste, which I do in everything. But the coming back to it, I think like I've forgotten how to find the answers that I need. We did see up here running the tests, the sometimes debugging that why did that particular thing not work as I expected. I've really appreciated being able to use debuggers with TypeScript. It's in the browser, but yeah, that has been helpful. Just like stop it right there. So maybe later what we can do is if we come back to this test, these tests that are failing, where we were not getting the OpenTelemetry spans. Interestingly, you see there's traces in there. There's the trace parent propagation. So we know that part's working. But why were we not getting the spans emitted? That might be something where I might throw in an IAX pry in the middle of the test or something. Okay, so we're at least clean for right now. And thank you all for coming. I might do this again on a weekend. Drop me a note on my socials. They're all linked from my Twitch profile. If there's some other time that you think would work better, and let's call it. Thank you so much for coming, and have a great weekend.